Good day once again. I'm still your main host, Engineer Daniel. Um, I just get a comment on some of the discussion we had in the last episode, which we talked about on our discussion series. We are currently talking on the structural reinforcement schedule in the building industry, especially in the housing project. So, but the comment that I received to talk on the superstructural reinforcement schedule work, because the last time we talked, it was on the substructural. So this time, I would like to share with you on superstructure. That simply means the structure which has built up from the foundational level from the DPC. So how can we commence our superstructural reinforcement bar respectively? On the DPC substructural work, we have a projected pressure bar, the pressure bar which are for the pillars. And at this pressure bar, they are expected projected above the slab level. That means that we cannot afford to cast the starter bar that will be below the slab level. And that is the reason for that is to have a, a proper lapping length, which is also part of our calculation before we establish on the DPC starter bar. So for the superstructural work, if you want to, start on the forming work of the block work in order to embrace your pillars, it is fine. But same, if you want to establish your reinforcement work, the pillars respectively before you can start others of your surrounding work is also okay. But the approaches to the superstructural reinforcement bar is simply having the actual headroom, know the headroom entirely. If you know your headroom and you know the expected height, so the expected height plus the depth of the slab for the suspended floor. If you have a suspended floor, if you are not building bungalow, if you have a suspended floor, the total height from the floor, from the DPC floor to the top of the slab, if you have that calculation plus the extra lapping length, which I consider a minimum of 8 0.8 meter, 0.8 meter minimum to be observed, so that you will not compromise so the level of reductions. So the lapping length should be observed 0.8, and if you calculate calculate that your 0.8 plus the initial height of the headroom, it's giving you approximately, let's say we have 3.15 of the headroom, and plus the lapping length if you are observing the suspended floor, that is 3.15 plus 0.8. So what are we looking at? We are looking at 3.95 respectively. So if you have that calculation, by the time you inserted the introducing column bar to the existing projected starter bar, it will enable you to have a proper lapping length there. And when it being projected after the slab work being casted, then you're also going to have an extra lapping length of 0.8 minimum. You can make it 0.9, can make it 1 meter, fine. We're looking at the standard and enabling the adequate um, structural integrity. So this is what we are looking up to. So if you have that, there is no need that if you want to introduce the projecting reinforcement bar on the suspended floor, the lapping length will not be short for no reason. So because there is no way you're going to block or break the slab, there is no need for that. There is no need to break the slab because when you break the slab, at the process of even hitting alone, you are losing the compatibility of the casted slab. So we don't come to negotiate in terms of that. So what we do to prevent that, you have to do your proper calculations and have your accurate measurements that to have overall coverage so that everything will be intact. So by the time you do that, after the casting, the suspended floor will have its own adequate lapping length. So that is it for that. And the next episode, maybe I'll likely to discuss further on cantilever on the slab work. So this is what I should come to address for now.